identifying and calculating areas and volumes. So the first thing we need to know is what does a right solid or a right prism, we'll say solids because one of them in here is not a prism, look like? Question. Oh, okay. Why? I'm going to tell you. All of these are examples of right solids. And what makes a solid a right is that it has two bases that are opposite from each other. They are the exact same shape. They are parallel to each other. And the sides connecting them form 90-degree angles. Now, in this specific prism, if this is classified as the base, there is another one on the direct opposite side of it. Okay? These two bases we could call rectangles, and the height of the object would be the distance between those two rectangles. Here, we always want to choose the more complex shape. Well, rectangles and squares are pretty much the same, so it really doesn't matter, but I'm going to show you something different. If I chose, let's say this is a square, which it doesn't look like it now because it's at an angle, but let's pretend it was a square, and I called that the base, then that means the opposite square is the other base, and the height of the object would be the distance between those two bases.
You did it the other way.
Here, the more complex shape, I have a bunch of rectangles that make the sides of this object, but the most complex shape is the front here, which would be a pentagon. All right? So, I have one base here, which is a pentagon. I have another pentagon on the back side, and the height of the object would be the distance between those two pentagons. All right? Now, this top one is not a prism. We would actually call it a cylinder. But still, and you can kind of see this line here, think of a can of corn. All right? The top of the can is a circle. The bottom of the can is another circle. So the base in this shape would be a circle, and the height of the object would be the distance between those two circles. This is the picture of a tent. Would the rectangles classify as the base of the tent, or the two triangles?
Yes.
Remember, the bases, you need to have another side parallel to it. Here, and nobody at home can see this, but here is an example of what a tent would look like. Is there another rectangle parallel to the base of this? No. And no matter what side I turn it on, you're not going to have another one parallel. But when you look at the triangles, is there another triangle exactly like it parallel to it?
Yeah.
Yes. So in this is called a triangular prism.
Why is there a hole in it? Why doesn't there have a hole? It's full.
The base of this triangular prism would be a triangle, and the height of it would be the distance between those two triangles. Now this is a house. It's actually two prisms put together. The house part itself here could be this, and the roof is just like this. So it's actually two prisms put together. You have a rectangular prism and a triangular prism put together. All right? But in the roof, what would be the base? This part here and the other side, which means the height of that triangular prism would be the distance between those two. For the house itself, I could choose any side to be the base. I could choose the side wall, the front, or the bottom. The height of the object will change based on what you choose to be your bases. For instance, using a manipulative here. If I stand it up this way and call what's on my hand the base, then the height of the object connects these two. But if I put it this way, is the height of the object still the same? No. Now the height is this little section, the distance between the two bases. Okay? So it's important to be able to identify those things. All right. Now tonight you're going to be finding lateral area, total area, and volume of right solids. And we have a general formula that can be used to find the lateral area of any right solid. So all of those pictures that we just looked at, including the cylinder, this will work. The lateral area. By the way, if I say I have an equilateral triangle, that means that the triangle has equal what? Sides. Lateral means sides. The lateral area is the area of only the sides. In the project that we're doing, we are finding the lateral area of something, of all of our rooms. What is the lateral area that we were finding? Your wall coverage is your lateral area. It's just the area of the walls, the sides of your room. All right, well, the lateral area can be found by the perimeter of the base multiplied by, and I'm going to change this to a capital H because I don't want us to get confused later, the height of the entire object. All right? The perimeter of the base multiplied by the height of the entire object. Now, we are going to look at this. It is a prism. We could more accurately call it a pentagonal prism because the base is a pentagon. And if we wanted to find the lateral area of this specific prism, we would find the perimeter of a pentagon, and we would multiply that by the height of the whole object. Okay? Well, in this specific pentagon, the perimeter is found by adding the 5 sides together, which would be 10 plus 8 plus 6 plus 8. Oh, plus another 6. All right? So what's 10, 8, 8, 6, and 6 add up to?
A lot.
Hang on. 12, 22, 30.
That's to find the area on sides,
Just the sides.
30.
Okay?
not bases.
Not the bases. This is just the lateral area. All right, so the perimeter here is 38. And we need to multiply that times the height of the whole object. Remember, the height connects the two pentagons. So what measure is that?
5.
5. And 38 times 5 is 190. If this was given in feet, it would be square feet. Yes.
What's it called when all the sides?
When they are congruent,
Yeah, when everything's congruent.
it's a regular
Regular.
pentagon. All right. So the lateral area of this shape is basically the area of only the sides, only all the rectangles. Okay? Any questions on lateral area?
Yeah. What's it gonna say if it asks for the lateral area of just one side? Is it gonna say? the
It's not
area
going to call it the lateral area.
Okay.
The lateral area is the area of all the sides. All right? Another thing you're going to be finding tonight is the total area of a prism. Which guess what? It's all the sides plus the two bases. Now we just said if it's a right prism, both of those bases are exactly the same, correct? So you can find the area of only one base and double it. And that gives you the top and the bottom plus all the sides. Now this formula can be applied to any one of these prisms, whether it has a triangle as a base, hexagon as a base,